Good morning, dear students. Last class I told problems on inverse functions. Inverse functions means a function f becomes, that is f forms both one and onto function. In that time only we are telling that f is becomes invertible and f is said to be inverse function. That is, before that also we have finished the problems on one and onto functions. One and onto functions means if f becomes both, in that time also we are calling f is bisective function. And today I am going to starting the new concept, that is the concepts of composition functions. In which time we are telling the functions are composition functions. Composition means by seeing that or by hearing that name, composition means combining. The combined two functions will get one new function. No, that new function is called a composition function. Let us now, I am going to giving the definition of composition function. At the same time, after that, we will solve the problems on composition functions also here. Now let us, what is meant by composite function now? Composition functions here. Composition functions. If you want to give definition to composition functions, we need three sets. We need three sets here. How many see here? Two functions at the same time, we define two functions also. We need two functions and we need three sets. It is f maps from a to b, one function, and G maps from B to C. With the help of these two functions, I am going to giving a definition of composition functions here. So diagrammatically, easily we can analyze how we are going to defining definitions of composition functions here. So here, let us, I am going to taking three sets here. One set is capital A. Another set is capital B, and another set is capital C here. Like that, I am taking here three sets. F maps from A to B, one set. B maps from G maps from B to C, one set. Like that, here one element x you consider here. Here y is equal to f of x, because these are all images of the function capital A. Next here y is there. No, here we can consider z is equal to g of y. Y element, here z is the images of the function g, and y set b is the, in set b we are going to collecting images of the function f. Here inside C, images of the function y. That's why I have taken three sets. With the help of all these three sets, I defined two functions. That is f maps from A to B and g maps from B to C. Firstly, I told no, we need the three sets, and at the same time we need two functions to give the definitions of composite functions. Composite means combination. Combination means combining of the two functions. Like that, you can combine means you will get one new function. That new function is called composition function. But mathematically we are calling that composite function, not combining, not combination. Composition functions here. Combine and combination, nothing but composition. That's what, instead of those, we are going to using the words composition functions. See here, Consider, you can take the last state z is equal to g of y. Consider g is equal to z is equal to g of y here. G of y here. Z is equal to g of, instead of y, what we got already in the from second set, instead of y we got f of x. It is the f of x, or it can be written as g circle f of x, g dot of f of x, g dot of f of x. That's why from this we can write here these two equations, if you can observe, left hand side parts are equal, then definitely we can equate their right hand side parts also. That's what we can write, g circle f of x, g dot f of x is equal to g of f of x. It is the composition function definition. From these three diagrams, the three sets, and from that concept we can give a definition of composition functions. How means, I'll tell you now. Let f maps from A to B and g maps from B to C, then the composition function of the composition function of f and g is given by g circle f of x is equal to g of f of x. G of f of x, that is the g circle f of x is equal to g of f of x. Mapping for this function is g circle f maps from A to C. F maps from A to B. G maps from B to C. But G circle F is maps from A to C. Reverse F circle G maps from C to A. Direct C to A becomes F circle G. But A to C means G circle F. But all these elements are living, but just we are including the elements of set and set C. When you are going to combining these two functions with help of all the three sets A, B and C here. That's what here G circle F can be written as mapping. With respect to mapping, we can write for the function, we can write for the composition function G circle F, it's mapping from first set to last set. That is the G circle F maps from A to C here. If you can come conversely, that is inversely, that is the C to A becomes, C to A means F circle G maps from C to A. That is also one composition function, but we are going to reversely. It is moving from A to C. For G circle F means we are moving from A to C. For F circle G means we are moving from C to A. This is the concept of composition functions of the two functions F and G. That's what we can give here. Let F maps from A to B and G maps from B to C. are the two functions, then the composition functions of the functions f and g is given by g circle f of x is equal to g of f of x. Because it's a dot, we can call it as dot also, no problem. Because it is circle shape, no, very small circle, no, that's what I'm calling it as a g circle f of x is equal to g of f of x. Or you can call it as g dot f is equal to g of f of x. So no problem. Based on that, we can give some important points under the note also here. Say here. Note means we can call it as no. Under this note we can give some important points here. Number one is g circle f of x is equal to, we can write g of f of x. Second one is f circle g of x. F circle g of x can be written as f of g of x. Third one is g circle h of x. We can define like that so many composite functions like this. G of h of x. Fourth, h circle f of x is equal to f of h of f of x. Like that we can give so many formulas here. Otherwise you can do like this also, no problem. Fifth, h circle g of g circle f of x. About this, how we can write means here h of g of f of x. Like that also we can give definitions. Because why I'm giving like all these important points means, when you are going to solving the problems on composition functions, at a time we need like all these important concepts here. That's what, after completion of definition of composite function, once again you see like all these important concepts here. Next afterwards, they are very most useful concepts. They are very most useful formulas to solve some biggest solution the problems in case of composite functions. That's what I told, like all these important concepts here. Now let us, we are going to solve in the problems on composite functions. First question, exercise 1.3, first question. Let f maps from the set 1, 3, 4 to 1, 2, 5 and G maps from 1 to 5 to sort of the elements. So the elements 1, 3, 1, 3, 1, 3 is given by F is equal to set of the elements 1 comma 2, ordered pairs, set of all the ordered pairs here, 3 comma 5, 4 comma 1, and G is equal to 1 comma 3, 2 comma 3, 5 comma 1, 1 comma 3, 2 comma 3, 5 comma 1 here. And what is that function from this onwards here? 1 comma 3, 2 comma 3, 5 comma 1. First, I'll tell you solution to this question through diagrammatically. Actually, in two methods we can solve this question. In two methods. First, I'll tell you first method diagrammatically, and afterwards I'll tell you some general formulas method. By applying a comparison function formulas also will get same answer. I'll show you we are going to getting same answer in both two methods here. How means now let us we are discussing about solution of this problem. Solution for this question. First method is diagrammatically. I'll tell you. Diagrammatically I am telling now, because if you can move through diagrammatically, it becomes very easy to us. It becomes very easy to us if we can move through the diagrammatically. Diagrammatically it becomes very easy. See, I'll show you how it is becoming easy to us. Now I am going to taking three sets here. One set is you can consider capital A. Capital A elements are 1, 3, 4, and B set elements are, and B set means the common, it's the common to both F and G. 1, 2, 5 B here. Last one is C set. C set is here. C set is here. 1, 3 here. Let us, we are going to mapping from A to B as F function F here, and B to C have taken the function G here. Now first 1 to 2 here. Next 3 to 5 here. Next 4 to 1 here. Next come to from G function 1 to 3. This is the B to C. 1 to 3 here. 2 to 3 here. And 5 to 1 here. Next A to C means composition function G circle F. G circle F is equal to 1 to 2 and 2 to 3. Exclude 2, you will get to 1 and 3 only. All these elements are excluded. All the elements of capital set B, they are leaving. Just we are including A elements and C elements. But which elements you are getting? But if you want to know which elements you are getting for G circle F, we must and should need the set capital B. After getting the element, leave it, no problem. Up to getting in, just put that set B there, like this. 3 to 5 and 5 to 1. 5 exclude, 3 comma 1 here. 4 to 1 and 1 to 3. Exclude 1, will get to 4 comma 3 here. That's all. By applying formulas also, you will getting a same concept here. Say, we are getting same concept means how we are getting the same answer in a second method also, we are going to discussing about that here. Second method for this question is the first method. Next, second method. Solution for this question is second method. Second method is for f, they are giving the elements are, what are the given elements for the function f? 1, 2, 2, 3, 5, 4, 1 here. G, the elements of G are 1, 3, 2, 3, 1, 3, 2, 3, 1, 3, 2, 3 and 5, 1. First method I told through diagrammatically. We got some answer. 1, 3, maybe 3, 1 and 2, 3 like that elements. Same elements here also you will get. See here, I will show you. Here in this function, f of 1 is equal to 2. In this, for this ordered pair 3, 5 is f of 3 is equal to 5. F of 4 is equal to 1. Like all the elements we got from the function f here. And this also, g of 1 is equal to 3 here, g of 2 is equal to 3 here, g of 5 is equal to 1 here. First set is, what is the first set elements? First set elements 1, 3, 4. Here I told now. First set f maps from 1, 3, 4 to 1, 2, 2, 5. Next, G maps from 1 to 5 to 1, 3 here. First set to take. To all this first set elements. What are the first elements here? 1, 3, 5. That's what here 1, 3, 5 you can take, means here consider first elements. Consider G circle f of 1 is equal to G of f of 1. Because G circle f of x formula what I told? G circle f of x. G circle f of x is equal to G of f of x. This formula here we have to apply. This formula. G of f of x. That is G of, for f of n how much they gave? 2 here. For g of how much they gave? 3 here. For this first element is 1, last element is 3. That's why we are getting one ordered pair 1, 3 here. Next come to second element 3 there. From that first set only, we must select all the elements here. G circle f of 3. G circle f of 3 is equal to G of f of 3 here is equal to G of, what is f of 3 here? 5. What is G of 5 here? 1. For the second element we are getting one more ordered pair, that is 3, 1. Next one is last element 5. G circle f of 5 is equal to G of f of 5 is equal to G of f of 5 is how much here? F of G circle f of here 1, 3, 4. 1, 3, 4 here. G circle f of 4 is equal to G of f of 4 is equal to G of f of 4 is how much here? 1. G of 1 is how much here? 3. That's why the last element 4 comma last element is the 4 comma 3. You check diagrammatically also we got same answer, and before this we did know we got these elements only. What are these elements means here? 1 comma 3, 3 comma 1, and last one is the 4 comma 3. Like that we are getting same elements only here. That's what here. Finally we can write G circle F is equal to G circle F is equal to first element is 1 comma 3 and 3 comma 1 and 4 comma 3 here. Like that if we can move diagrammatically, or if we can move through the formula, that is the according to definition of composite functions, you are getting same answers here. That's what we can apply this method, or you can apply diagrammatical method also. There also you will get same answer. Now let us, we are going to solving some more questions now. Now we are discussing about how to combine some algebraic functions, because just if you can solve some general algebraic functions in case of combining of two functions, then easily we can analyze and easily we can solve composite functions very easily here. So how to combine them algebraic functions here? For that we are showing that combination or composition of functions with help of some functions here. So example 1 here, number 1, f of x is equal to x square and g of x is equal to some 2x plus 1. Then how can you apply these functions here? Find g circle f of x, g circle f of x, and find out. Second question, you can write f circle g of f of x also, f circle g of f of x also. Solution for this question is, let the given functions f of x is equal to x square, g of x is equal to 2x plus 1. First question, consider g circle f of x. G circle f of x. What is g circle f of x? G of f of x. What is f of x here? X square. What is g of x is there? 2x plus 1. X means x here, but g of x square becomes 2x square plus 1. This is the G circle f of x. Like that, we are going to combining the given two functions here. G circle f of x is g of f of x. That is a g of f of x. F of x nothing but they gave x square. Then g circle f g of x is 2x plus 1. Then g circle f of x is 2x square plus 1 here. Next one is second question. F circle g of x. F circle g of x. F of g of x. F of g of x is 2x plus 1. What is f of x? X square here. F of x is equal to x square means we can write here 2x plus 1 whole square. You apply a plus b whole square formula here. A square plus means 4x square plus b square means 1 plus 2ab means 2 into 2x into 1 4x. It is the what we can write here f circle g of x. F circle g of x is equal to 4x square plus 4x plus 1. It is the f circle g of x. Like that, we combine the functions means we are calling composition functions with help of those formulas. G circle f of x or f circle g of x. Like that, today I told definitions and concepts of composite functions. At the same time, we have finished two problems on the composition functions. Next class, I'll tell you different types of problems on composition functions. Thank you very much.